Okay, at this time, I would like to introduce our speaker, Kevin Boucher. Kevin has been retired for almost 10 years this coming November. He was a software consultant for 30 plus years, traveling many places around the country and the world, developing new software systems for companies. For a couple of years, he traveled to many of the largest cities in the country on a paid speaking tour on IT-related subjects. Kevin got into astronomy on his 10th wedding anniversary, which was over 25 years ago, when he and his wife traveled to Sedona, Arizona, to a resort, and an amateur astronomer was positioned on the roof of the restaurant at the resort every evening. He couldn't get enough of it. Soon after, he bought his first telescope, and a few years after that, started in astrophotography with the first mass-produced amateur CCD camera from Meade called the Deep Sky Imager. He's been trying to improve his astrophotography hobby over the last 25 years as the technology has changed. Okay, please welcome Kevin Boucher.
Thank you, everybody.
Lights.
Slides. All right, good. Looks like we're operational.
Okay.
All right. Well, first of all, I want to thank you guys for inviting me down here. Actually, Russ Chaplison asked me if I'd be willing to speak, and I'm always happy to, basically bang my gums in front of people. I enjoy speaking on a lot of different topics. These days, it seems to be I do a lot of stuff on astrophotography. It's just a hobby that I'm really into. So we talked a little bit about my background, but what you probably don't know is I'm the founding member of the Aldridge Astronomical Society Imaging Group. So I forget when I founded it, actually. It's probably close to 14 years ago, something like that. It's just kind of an informal group within the club. We kind of have our own sub-meetings, more to learn things. We're trying to learn from each other, try to get everybody better at the hobby. So it's kind of a more of an informal thing, although we do meet on Zoom. We do try to meet up. We go to various events that are astrophotography related. I currently hold the IT/membership director board seat for Aldridge. I've been trying to improve my astrophotography skill set for 25 years. I'm still working at it. And we've already talked about this, so I won't spend any more time. So what I'd like to know is to get to know you folks a little bit. How many people use PixInsight for image processing? So we got a couple. All right, so hopefully I don't lose too many of you. For those of you that never heard of that, it's just an image processing software. And some of the AI tools I'm going to be talking about tonight run within PixInsight, but you can get some of these to run outside of that tool. So I guess what I'm trying to say is some of the things I'm going to talk about and the workflow ideas I'm going to bring up, you can actually do outside of PixInsight. So don't discount any of them. So how about Photoshop? Yeah, so we got a lot more people using Photoshop. That's fine. And that's where I started out also. I was using Photoshop for a very long time. CCD stack was another. I don't know if anybody's still using that, but that's another one that I used to use. So does anybody currently use AI for any of their imaging processing? You do? What are you using?
I have BlurXterminator, NoiseXterminator. I've used Grabert.
Okay.
Expert to noise. I've tried it. Awesome. Awesome.
Yeah.
Man,
Okay. And you said you use
I just use StarXterminator.
StarXterminator. Okay. Very good. All right. So my equipment. This is my backyard observatory. I have basically an 8x10 roll-off in my backyard. It's with an Astrophysics 900 GTO mount that I bought used a bunch of years ago now. I have a GSO 10-inch carbon fiber Ritchie Christian, and with a focal reducer. So it brings my my setup down to f6, about 1500 millimeter focal length. I use a Moonlight focuser with a high resolution stepper motor for automated focusing. And for my guiding and for wide field work, I have a Williams Optics 81 GT APO refractor. You can see writing on the top there. For my imaging camera, I have a ZWO 2600, very popular camera nowadays. I love this camera, it's awesome. with a 7-position filter wheel. I just bought the Antler 4.5 millimeter narrowband nanometer filters, but I haven't really had a chance to play with those too much yet. And for my guide camera, I currently use the Starlight Express Lodestar X2. So the software I primarily use now, I use Nina for all my image acquisition. Anybody else use Nina? Okay. I love it. In fact, if I wasn't using my laptop here tonight, I'd be running an automated session on my observatory at home, probably as we speak, you know, so I love it. For image processing, I pretty much do everything in PixInsight now. I don't even have a license to Photoshop anymore. I do use GIMP occasionally, but not very often. All right, so the AI functions that we're going to discuss tonight is StarXterminator from RC Astro, NoiseXterminator from RC Astro, BlurXterminator from RC Astro, and we'll talk a little bit about Grabert, including the very latest version 3 release that has noise exterminator built into it, basically. So let's talk a little bit specifically about StarXterminator and basically how it's kind of affected my life cycle in my image processing. So this is the AI probably with the single biggest overall impact to how my workflows change. And I'll try not to, you know, bore you guys or kind of get anybody lost on this. And the reason for that is the ability to take your stars out of the picture and process your DSO and your stars separately is just gives you amazing possibilities, okay? And I'll try to convince you of that. And you can this is an example of something where you can actually not use this tool within PixInsight and use a tool like StarNet++, which is an open source type tool that you can run outside in Windows I'm not sure if it runs on a Mac also, but you can certainly run it in Windows as a separate product, you know, so you don't have to have PixInsight in order to use, do a StarXterminator type of process. So I like to separate my DSOs from my stars because I like to stretch them differently, okay? A lot of people have problems where their stars are either blown out, have no color whatsoever, or if you're stretching both of them at the same time, you may be overstretching your stars and you're not stretching your DSO enough. DSO being your deep sky object, whatever it is, a galaxy, a nebula, or whatever. And especially if you're working with dim nebula, it's just so dim and the stars are so bright, especially if you're shooting anything within our galaxy, you know, within the plane of our galaxy. So you really want to stretch them differently, and that's at least how I do it. I like to stretch the DSO only image to maximize the detail in all the fainter areas. So I don't blow out the brighter regions, but I want to really brighten some of the very dim stuff. And I use generalized hyperbolic stretch. That's kind of the tool that I use in order to stretch, but you can use whatever you like, whatever you happen to work with. And it's also a great way to correct any background artifacts. Now, if you're having like a light glow from an off-field star that is kind of infecting your image, or you may have lights that you can't get rid of that are one of your neighbor's lights or something like that that are encroaching in on your field of view. When you extract your stars from your DSO, you now have that background by itself, and you're able to even use like clone stamping tools in order to correct those things. Unless, of course, they're encroaching directly into your nebula, which you can still do some creative correcting, but at least you have the opportunity to do that. It was very hard to do it before. For me, I stretch my luminance stars only image to control both the number of stars and their intensity. So I don't need to use any star reduction routines anymore. I don't know if any of you have ever used like Photoshop Minimize, or, I mean, there's so many tools that we've used over the years. And what you generally get, if you don't watch it, is you get these little wormy figures in your stars, in your star fields. And you can get away from all of that by simply stretching your stars only so that you can control whether you want all the stars. So if you're shooting anything around Cygnus, let's say, you know you're going to get 1 million stars. Sometimes those stars just overwhelm the picture that you're actually taking a picture of, right? So what I like to do is I like to stretch my stars separately, and I control very much whether I have, I only want like the medium to bright stars to show, and I don't want them to overwhelm the image, and I may not even want the really dimmer ones to show. So you can really kind of control that in the stretching process and not bother with any of these star reduction routines that generally cause artifacts in themselves. I like to use the arcsine stretch algorithm in GHS to stretch my colored star images, primarily because I think it retains the color in the stars without burning them out. That's my particular preference. And I sharpen the luminance in the narrowband DSO only images, but not the stars. So I do all of my I never sharpen my stars only images. I only sharpen my luminance and narrowband, DSO only images, so that, let's face it, the luminance is really a framework for your whole picture, right? I mean, that's basically where you're getting all the detail in your photos. So that's where all my sharpening is going on. And I find overall that StarXterminator generally works better than the alternative AI star removal tool called StarNet++, which I talked about already. But that is an option, okay? So that is something that you can do. Now I'm going to get into more detail on this. Now, I don't know how well these pictures are going to translate to you guys in the back there, but I mean, this one is one that certainly can, in that you can see we're starting out with this picture here. This is the original Flaming Star Nebula photo, and you're separating out the DSO only from the stars. That's all this is meant to show. That's the purpose of StarXterminator or StarNet++. All right, the next one we're going to talk about is NoiseXterminator. Now, I don't know about you guys, but I used to use multilinear transform. I've used mask with convolution. I've used a lot of different techniques over the years to get rid of that background noise. And inevitably, no matter what I did, I'm always blurring some of the detail in my targets, whatever it is. No matter how hard you try, you get a little bit of blur in that nice fine detail that you're trying to really hold on to. So I used multi-scale linear transform for a while with masks, and you can tweak and tweak and tweak, and you can get some half decent results, but I find that NoiseXterminator does a far better job. Every previous technique tended to blur not only the noise layer, but some of the fine details in the DSO. NoiseXterminator does preserve those details. Very, very good, I find. So here's an example of a really zoomed in section. And I don't know if you can see it in the back, but there's a lot of noise in this picture here all around. And then when we go to the after, this is after NLT, noise reduction. So you probably can't see this very well. The noise is really kind of gone using NLT, but it did blur the fine details in the nebula here, okay? And when you're using, I thought I had another frame in here, but I guess it's not coming in. I did. Yeah, oh, here it is. This is after NoiseXterminator, and this is after MLT. So NoiseXterminator just does a lot of much better job in preserving the detail in your nebula. That's all I was trying to get across here. All right, so BlurXterminator, the last product. By the way, these are all the sequence of how RC Astro introduced these tools over the last three years or so. And it's really been a wonder for me anyways, in terms of how my pictures are coming out. So BlurXterminator is, for all intents purposes, is a deconvolution tool, not a sharpening tool. We're going to talk a little bit more about what MTF is in a minute. But what I love about this tool is that it does an incredible job of correcting for any scene issues that you're going to have whenever you're shooting in New England. Anywhere in New England, you're going to have scene issues. So it's going to blur some of that fine detail, okay? And I find that BlurXterminator does an amazing job not only of correcting some of the fine details in the DSLs, whether it's Galaxy or Nebula or whatever, but also in correcting your star shapes. So if you've got a situation where you're using some kind of an optical system that has off-axis type of star elongation in your stars, this tool does a great job of correcting that, so that your full field is going to start looking really, really nice right down to the stars. Now, this is the AI, in my opinion, that had the single biggest impact for me, the fine resolution of my images. Now, not just because of the tool, but because I'm using this tool, I am now shooting at the highest possible resolution that I've never done before. I've always been taught, and I'm sure you astrophotographers out there have heard this, we have to shoot at between 1 and 2 arc seconds per pixel resolution. Well, that's not true. Not if you're using a tool like this. I shoot at 0.5 arc seconds. And you know what? I'm retaining all that detail that I'm gaining by what people would call oversampling your pictures. I'm not oversampling, in my opinion, at least when I'm using this tool, because the main reason why you don't want to go to that high resolution is because of the scene conditions. Well, guess what? BlurXterminator does a great job of compensating for that. We're going to talk a little bit more about this when I talk about MTF in a short bit here, but I'm really impressed. I was actually amazed. I was a very big skeptic of shooting at binning 1 by 1 with my rig and at shooting that high resolution, and it's proved to be the best thing I ever did. I also find BlurXterminator is so much easier to use other than the deconvolution tools that you can use out there. You know, there are a number of deconvolution products, including the one that comes with PixInsight. I don't know about you folks, but I have used that tool and I can spend 2 hours on it to try to tweak those settings where I'm not getting the panda eyes, I'm not getting worms, I'm not getting all these artifacts that are coming into the photo. BlurXterminator does all the work, bing, you're done, and it does a great job. If you haven't tried it, I absolutely highly recommend. There's absolutely no ringing the stars ever, no worms compared to what I used to have to work around with deconvolution on all the other tools that I tried. And I've tried a lot of different deconvolution tools over the years. It also acts to not only minimize the star bloat, which you get if you quote unquote oversample your pictures, but also to correct the star shapes, which you're going to get on nights with bad seeing, right? I mean, and if you have any kind of optical aberration in your optical train. So honestly, it's just a kind of a catch-all type of tool for correcting a lot of things. Now, this is a picture I know that you're probably not going to be able to see back there, but I figured I had to throw a frame up. But you can see this is before BlurXterminator, a very zoomed in area, and this is after BlurXterminator. And you probably can't see it, but there, the features, the fine details in the nebula here are just really.
Pointing is the best example, I think.
Yeah, yeah. I mean, and what's really cool is this is just a stepping stone, right? If you can reclaim that detail that you're losing because of seeing, amazing what you can do when you start sharpening, you know, using tools like MLT or whatever sharpening tool that you happen to like to use. Now you're exaggerating some of those features that you never saw before because they were just blurred out as a result of seeing. So it really is amazing what this product has been able to accomplish. And I think Russ deserves a lot of credit with the work he's done on this product. It really did a great job. And it gets better all the time because he comes out with iterations on a regular basis. All right, so here's where I try not to bore anybody, but this is where I make a case for why you want to basically consider going with a higher resolution, especially if you're using deconvolution the proper way, okay? So this tool, by the way, this free MTF Analyzer is on the RC Astro website. It's free. It's just a screen that you can go to. I pop this screen here up so that you can see it easier, but if you can see it's in the background here. This section here is on the top of the screen. You only get one screen that it pops up. And what you do is you basically put in all the parameters of your optical system and your camera. So in my case, I put the parameters in for my setup. okay? And so that's what you're seeing here, all right? And you can see I have none in terms of whether I'm drizzling or binning down here. And if you look at the bottom, it gives you the results, okay? And what you're looking for is if any of these results are colorized. So if it's red or orange, you're either oversampling, you're undersampling. Well, none of mine at 0.5 arc seconds a pixel, I'm not undersampling or oversampling. Well, certainly not undersampling, but I'm not oversampling at all because none of the colors here are showing as, I think it's red, or no, it's orange if you're oversampling. Okay, so, and that is all based on all of the information on your optical train based on your seeing conditions. And it's assuming, I think, that if you use this BlurXterminator product to correct for those seeing conditions, which is the only variable in this equation here, you can get the optimal resolution. So let's go to the next frame. You can see what I was talking about. This is what I currently have without any binning. You can see at the bottom here, it talks about red is undersampled, orange is oversampled, okay? I don't have any of that in my picture with those parameters. Now, if I go back here again and I change some of these parameters to 2x2 binning, which is where, you know, gets you to the quote unquote 1.5 arc seconds a pixel, guess what? All of a sudden now, I'm undersampled as far as this MTF Analyzer is concerned, okay? If I go to 3, well, actually this is still.
Yeah, the last one was.
The last one was 3? Okay. Yeah, okay, so that's 3. This is 2x2 binning, okay? At 2x2 binning, I'm sorry. At 2x2 binning, I'm at 1 arc seconds a pixel, and I'm still basically undersampled as far as the MTF Analyzer is concerned. Okay, so I currently do not bin anymore, and I find my pictures, my stars are sharp, and I get far more resolution than I ever got before. So you may want to consider trying it, checking out what this basically delivers to you for recommended image sampling. We'll talk a little bit about Grabert now. Now, this is a tool that can run entirely independent of PixInsight, or it can run within PixInsight as a process. This is kind of what version 3 looks like. It's pretty easy. It takes you basically down 1, 2, 3, 4, 5. You know, so 1 is you load your picture in. 2, you can basically crop your picture however you want to crop it. 3 allows you to do the background extraction, so that's basically flattening your image. Okay. 4 is denoising, so that's equivalent to their NoiseXterminator to get rid of the noise. And last but not least, 5 would be saving the results. Okay. There's a simple toggle, a drop down up here that shows you what your original picture looks like after all these steps. And if you want to see what it looks like after the step is performed, you can see the differences. You can go back and forth and see what it looks like. So I'll walk you through it. Crop. This is basically where you're doing the background extraction. So you're basically trying to flatten the background of your picture here. You can basically check what it looks like, with it flattened, with it not flattened, by using this drop down. It actually shows you the background also, so it shows you what it's extracting, if you want to see that. And then you fall into the denoising. You can set it at different strengths with this slider. And then, last but not least, you can save it. Now you can even save it as a 32-bit XISF. That's basically a native PixInsight image format, or you can save it in a number of other different formats. So my experience with Grabert has been varied. I've seen it work very well in some images, both for the background extraction and for the denoising. But I find that NoiseXterminator does overall a much better job on denoising. And in terms of background extraction, this tool, I primarily use this tool and the new gradient correction tool that PixInsight put out about 3 months ago. But you need to do a lot of tweaking with that tool in order to get a good job done. So this is the process in PixInsight for Grabert. So if you're running Grabert within PixInsight, you can do that using this process window here. So basically, it actually runs natively within PixInsight if you want to do it. All right, so now hopefully I don't bore you guys too much with this. This is exactly what my current workflow is, and I'll show you how the AI incorporates into it. And I'm sure a lot of you are going to say, oh my God, that is just way too many steps. And believe it or not, all the stuff that I do, I can generally do easily in maybe 4 hours or something like that. But I used to take days and days because you're doing trial and error on a lot of stuff. And now I've got it down to a point where it works pretty well. So I apologize for those of you that don't use PixInsight. I'm going to use terms you're probably not going to be familiar with, but I'll try to explain what they are. But I just simply start out with this WBPP script. Those of you that use PixInsight know what that is. But basically, I just calibrate and register, align my images. That's step one. Now, up until recently, I was using this normalized scale gradient tool. I've recently switched over to local normalization, and to explain to you what that is, all that really is you're trying to simplify the gradients in the background, okay? Because believe it or not, whether you know it or not, due to very high clouds, whatever the light situation is, wherever you live, every image that you take is going to be slightly different in terms of the gradients in your photos. So what local normalization does in PixInsight, or this normalized scale gradient script does, is just make sure that all the frames are the same in terms of the gradient. Simplifies things for at the end when you actually fix the gradient. Then I do image integration. Okay, so for me, I use a mono camera, so I use, I basically, take red, green, blue for color. I don't do luminance. I create a synthetic luminance, but I'll talk about that. I take narrowband if I want to take narrowband on the target. So I'm basically integrating all these separate frames. So I basically do image integration, and I create a synthetic loom from the RGB master frames that WBPP is grading for me. Okay. Next thing I do is I like to do a linear fit. Some people say it's not really needed anymore, but I still use the green master as my reference, and I apply linear fit to both my red and my blue master frames. Then I do channel combination, so I create my color master from my RGB masters. Now is when our first AI opportunity comes into play here. Okay, you can use Grabert at this point to actually fix your gradient, or you can use DBE, which is a tool that's been used for a long time in PixInsight, or the brand new gradient correction tool in PixInsight. I'm finding more and more that I like the gradient correction tool. I found some default settings that seem to work on most all pictures very well. So now for me, I correct the background for the color master, my synthetic loom, and any narrowband masters that I have at this point. Next step is I fix my color master by using spectrum photometric color calibration. So for those of you that don't know what that is, all it's doing is basically looking at all the stars in the image. It checks it to a catalog, and it says, okay, I know what color these stars should be. So it knows how to create the white balance for your photos so that it knows how to get the red, green, and blue ratios correct. So it's doing that quantitatively versus, kind of guessing, which I love. Now you know that the color is actually accurate. Now, the only thing for this tool here, you actually have to have a plate solved image so it knows what part of the sky it's looking at. And if WBPP didn't do that for you, you can use the plate image solver script in order to plate solve your image, or some other tool if you want. So obviously I'm only doing color calibration on the color master. So now you can see any of these red sections is where I'm using AI. So I use BlurXterminator at this point. Everything's still linear. I haven't stretched anything yet. So I use BlurXterminator on the luminance master, my color master, and any narrowband masters I may have. I use NoiseXterminator or Grabert for noise reduction at this point on the same masters. And then I use StarXterminator to start separating things, okay? I make sure I unscreen the stars from my deep sky object for both the luminance and my color master. And when I do it for narrowband, I don't save the stars at all. I don't want my narrowband stars. Okay, so I just separate the stars from the DSO, and I keep that separate so I can blend that in later on. Then I start stretching. Okay, so I'm stretching. I use GHS for all my stretching. That's how I do it. You can do it however you want, obviously. I stretch my luminance, my color, and my narrowband only, okay, without the stars, to maximize my detail. I stretch the luminance stars only to the point where I like the star size and how many stars I see in my picture. This is where I control the number of stars that are in the picture. I stretch the color stars to the point where I like the color. I like to use ArcSign stretch in GHS. You could use the ArcSign stretch tool in PixInsight if you wanted. It does a great job for keeping the color. And I love really colorful stars. That's just me. And now is a great time, if you need to correct any remaining artifacts before you recombine the stars in your galaxy or whatever, your nebula or whatever it might be. All right, so now is the time to do sharpening, okay? So I sharpen, I only worry about sharpening my luminance layer in any narrowband images. I don't bother sharpening anything else because really the luminance is your framework for your image anyways. So that's where all the fine details are gonna come from. So I sharpen my luminance and my narrowband masters to bring out all the details that I want before I recombine the stars, okay? Then I get to recombining the color and the luminance using, I use LRGB for that. And then I also recombine the stars into the picture. So now we're bringing the stars and the DSO all back together again. I do any color saturation I need to do at this point. Most often I don't have to do any because I stretched it in such a way that my color is very much preserved. And then, oh, this is where I just combine the stars. This is where I actually do the LRGB combination. So this is where I'm combining the color master with the luminance to bring them together. Last but not least, this is, if I have any narrowband, this is where I will bring the narrowband into my brand new LRGB image. I like to use this NB Colormapper script that Adam Block worked on with Canfield, I forget his name, but he's done a lot of some great scripts out there. It's from Cosmic Photons anyways. And this is where I use that tool in order to bring the narrowband stuff in. You can assign any color you want on the palette to your narrowband images, however you want to do it. And you can save that color palette. I think I might have a frame that shows you what it looks like. And then any final processing is unique to any image. You might want to do a final S curve with curves or whatever to maybe darken the background a little bit and raise your brightness of your DSO, whatever. But anything else is just, you know, final touch-ups, and then that's it. You finally finish off your workflow. So that's sounds like a lot, but believe it or not, it really comes very smoothly to me now. This is what that script looks like. I don't know if anyone's ever seen it, but so what you can do is you can load your color picture as a layer. I load it as layer 0, and then you can add as many more as you want afterwards. And you can assign whatever color you want here. And it does an incredible job at blending it into the image. This area here is the preview of what you're going to end up getting when you do your blending. So let's say you had a color image and you wanted to blend, you know, sulfur 2, oxygen 3, and hydrogen alpha. You can actually do that all with this tool if you want to. Just kind of keep playing around. I don't know why you'd want to do that, but you could. You can do that with this. Pretty cool. So, as a recap, the improvements that I've actually experienced by using this workflow with these AI tools, overall I have better resolution, image detail as a result of utilizing the full possible theoretical resolution of my optical system along with BlurXterminator to correct for that blurring that you get as a result of scene conditions. Better star shapes over the whole field of view Once again, BlurXterminator is doing that for me. It really does minimize the stars to a nice size, you know, so, you know, it lowers their overall impact in the image, which I love. Noise reduction of both the color and mono images without blurring details in my deep sky object due to NoiseXterminator and Grabert. Those are the tools that are helping me with that. As a result of the ability to process the deep sky objects separate from the stars, using StarXterminator, I have the following improvements. More detail in my dim DSO features without overstretching my stars or creating a lot of masks. Stars have more color because of the way I'm stretching them. I can better control my star size and the amount of stars without needing to use star reduction processes, which can leave those worms and all these panda eyes and whatever other artifacts that you're going to see. And overall, I find it's much easier processing without the need of a trial and error on deconvolution and noise removal, because I would spend hours on using the deconvolution tools and hours on using NLT to try to blur just the background and creating these masks without messing my fine details that I spend so much effort in getting. You know, so you get the best of both worlds, I think. So, of course, you got to end off with some recent pictures that I've taken using these techniques, and I don't know how well they're going to come out here, but this is my very first 2-panel mosaic, which was a panel of these two images here at the bottom.
How much exposure time roughly are you using to get images like?
I generally get exposures of 2 to 3 nights worth of exposures. Pardon me?
How many hours? Like
I run it all night long. See, with Nina, the beauty of it is I can let it run all night long. I just wake up in the morning and I go out and my mount is already parked. All I have to do is close my roof and power it down. So,
okay.
Yeah. The Flaming Star Nebula. This is a picture that on Astrobin the judges liked enough to, you know, award it as a image of the day candidate. M13 globular. What's nice is, you know, once again, this is where the resolution comes into play. You're able to see the stars right to the very core of the galaxy. You're able to see this galaxy here, a lot of the features in it. You know, there's a lot of, even this galaxy right here, you're actually able to see these very fine details, especially if you blow these pictures up a little bit. It's crazy what you can actually see for resolution, you know, which I love. This is another one, Astrobin, an image of the day candidate. But this came out very good, the Needle Galaxy. Now, these are all within the last year and a half, maybe, but certainly since I've been using the new processes I've been talking about. Once again, some of the details on these, you know, these galaxies over here, you can, if you zoom in on them with the actual pictures, it's crazy. You can see them really good. Some nice features, and they're small, you know, but you're still able to see the resolution on them, which is crazy. 730, you know, so basically the Deerlick Galaxy here and Stephan's Quintet over here. And you can see, I mean, some people would say, oh, I think these stars are way too colorful. I personally love colorful stars. That's me. Not everybody's got this taste, which is fine. You know, everyone's different, right? Cocoon Nebula. So these, this is my very first dark dust nebula. It was kind of fun to process this, to kind of bring it out from the background. Now, this is a classic example where I didn't want to minimize the stars in the background because it's really adding all the contrast to the target, right? I mean, it's backlighting the target, so you want to leave the stars here. This is in the, you know, in the area of the galaxy where there's just a million stars. You know, I forget, this is up near Cygnus, I think, too. But, you know, this is just a really pretty backlit type dust area. And that's it. If you have any questions, if we can turn on the lights here. Any questions? I'd be happy to answer them.
Can you
Go ahead first.
speak a little bit to the learning curve for Nina and PixInsight, people that aren't that familiar with it?
Okay,
So I heard
Nina-
they're a little bit of a bear and.
Yeah, you know what? Both of those tools, there's a million great YouTube videos. And if you, I'd be happy to pass them along to you guys. I know some great YouTube bloggers that do a wonderful job in teaching those tools. You know, so they're all free, which is great, you know. But I can say Nina is, I think, very easy to learn, especially if you're going to use the basic sequencer that they call. I use the advanced sequencer. I don't think it's that advanced, but it has a lot more functionality. I highly recommend going that route. PixInsight, on the other hand, you know, is definitely a steeper learning curve. There's no doubt about it. I mean, it came easier to me because I'm a techie guy, you know, so I kind of gravitated to it pretty well. But a lot of people,
But I think the RC products is simplified a lot of that.
RC products have definitely simplified a lot of it. There are a lot of intro courses on YouTube, once again, for PixInsight to learn the user interface, because it's very different than most other products. I like it. Once you get used to it, you love it, but there's a lot, you know, there's a lot to learn. There's definitely a steep learning curve, but I would recommend the YouTube videos. Yeah.
Yeah, please forgive me how I asked this question,
No, go ahead.
but how is this AI? And kind of follow up on that. To me, the eye intelligence, but the intelligence of the user who is making use of the software. To me, it doesn't seem like there's any artificial intelligence involved, at least in my way of thinking.
Well, there is. It's not really artificial intelligence. What it really is machine learning. They call it machine learning. And all it really is they give you a before and after picture. So what Russell Croman does is he takes a whole lot of bad pictures that need stars removed, that need noise reduction,
But
that
you're
need.
supplying the direction,
No, you're not.
you're not.
All you're doing is you're giving it a before, and then Russell does is he takes the same picture and he fixes it manually, tediously, hours and hours and hours on end. He gets the picture the way he wants it. And he tells the machine learning engine, which, by the way, you can get from Amazon. I mean, there is machine learning engines that you can get. He's just using some existing machine learning engines that have been written. And all these machine learning engines do is they do iterative over thousands of hours. I mean, he runs a very high-end machine for literally several months to try to get this picture to look like this picture using all this rules engine and it's building the rules itself. The software is building the rules. That's what the
So
intelligence comes in.
I had a misconception.
Yeah, that's how it works. And that's how all the AI products that he puts out works. He runs these tools through these AI engines that basically write, in essence, it writes a rule book of how to correct a picture, any picture. And that rule book is what you're buying. So when he sends you a product, it's just what you're actually buying is that rule book, is what it comes down to. That's really to simplify it, that's in essence what you get. Okay?
Thanks.
Yeah. And he does it with a lot of different pictures at different focal lengths, because you got to train that thing to work on anything. And so you got to throw a lot at it in order for it to get it to where you want it to go, right? So, any other questions? Yes, in the back.
How much does your workflow change if you're doing one shot color?
It changes quite a bit.
You have a lot of combining and
It changes quite a bit. And you know what? Most of the members in our club, we have some really good images in our club. Most of the members in our club are using one-shot color. And I think that's great. There's absolutely nothing wrong with it. The 2600 camera that I use has a color version. Awesome camera. Now, you lose two things when you go with color versus one-shot, right? I mean, when you go color versus mono. You lose resolution only because you're getting 4 pixels for the price of, for the one that I'm getting, right? So, 4 pixels in a color over the Bayer array is going to be converted to 1 pixel, in the end. So I'm getting 4 times the resolution. The other thing that you don't have the ability to do, although people are using narrowband like tri-band and quad band filters now on there. And so they're getting some aspect of what I have when I'm shooting narrowband, where I can shoot, you know, different narrowband. Before, these quad band and tri-bands and all these different filters that they're putting out now, you weren't able to do that kind of. Now you're kind of able to do it, you know. You're not, once again, using all the pixels, so you still lose that resolution, but you are able to do some of that narrowband work you weren't be able to do before.
What I'm doing is very similar, but I don't know where it changes. You know, because you doing a lot of combination of individual colors or whatever you want to call it.
Yeah, I do one shot color, and you just eliminate a lot of the.
Yeah.
Artificial
Cause I'll just WP.
It's easier.
Yeah, absolutely, a lot easier. It would definitely eliminate a lot of the steps that you showed in my work, so for sure. Go ahead.
Another quick question. This has to do with BlurXterminator, where it brings out additional details.
Yeah.
I don't know if this is possible. Can it be used to bring out additional details on images of the planets or the moon, or is it only for deep stars?
So that's a good question. It uses a point spread function, and it uses a point spread. Now, the answer to your question would be yes, if you had stars in your planetary images, because it needs a point spread function. Now, if you could create if you took a picture of the stars like in the area, and you got a PSF measurement on the stars, you can do deconvolution on your planet using that point spread function. But that's how BlurXterminator works. It first analyzes all the stars in your image.
Mm-hmm.
You can even select the ones that you wanted to just look at if you want to do that. But it looks at all the stars and it creates a point spread value, point spread function value, and that's how it basically does the deconvolution. So it's not sharpening, once again, it's reconstruction is what it's doing. It says, okay, your image is blurred and it's blurred like this. I'm going to do the reverse and unblur. That's kind of what it's basically rebuilding your photons, you know, based on how these stars are skewed, you might say.
Question about the term you use, stretching. Is that changing the dynamic range of the image?
Yes.
Okay.
Yes, that's exactly what it is.
Right.
Yeah. Yeah. So you're compressing the dynamic range is what you're doing. Yeah. Because everything is piled up on the left side of your histogram. For those of you who know what histograms are, everything's piled up on the left side in the darkest areas. You look at a picture that you took, even if it's 15-minute exposures, most of the time you see nothing except for maybe a little bit of stars. But you won't see anything else. And that's because we're taking pictures of really dim stuff, right? So what we got to do is we got to brighten it. So what we're trying to do is we're taking all the data that's piled up on the left side, the dark side of the histogram, and trying to stretch it out to the white side of the histogram without going to the white, and trying to, you know, basically bring all those grayscales up. And that's basically how it works. Sure.
You talked about something I hadn't seen before, which was, if I was following right, plate solving for color correction.
Yes.
What is the source of truth for that? Do you know what I mean?
Yes.
What
Well,
is
all the stars are, you know, whether it's a G2B star, you know, there's all these different star classifications, and they all have their intrinsic colors.
Yep.
That's what it's trying to get. So it does a
just
plate
for stars? It doesn't-
just for
not
the stars,
gas.
yeah. So if it knows what the color, it's trying to figure out the color ratios, and it says, okay, well, I'm seeing these stars and they're this color on your picture when they should be this color in reality. So now it says, what's the difference in the color ratios? And it fixes your image entirely in that respect. Does that make sense?
Gaia catalog.
Pardon me? Yes,
Yeah.
uses the Gaia catalog. That's what PixInsight uses. You can download the Gaia catalog and it uses it right on your laptop. So,
Sorry.
yeah, go ahead.
Quick. What kind of subs are you using?
So
And also.
in terms of exposure time?
Yeah.
Okay.
And also, after all of this is done and you've mastered all this, does it then qualify you to construct an atomic bomb?
Good question. No, the answer is no to that last one. My subs are, for my RGBs, I take 5-minute subs. Okay. And for my narrowband, I'm taking 15-minute subs. But I have a good amount. You know, I can tell you, I've gone through all the craziness over the years. You know, like I said, I've been doing this for 25 years, and I've had absolutely horrid pictures, more than I can count. You know, and you just keep trying to make corrections. you know, all of us in our group, we're all doing the same thing. We were like leapfrogging. We're gonna go to the next best mount, the next best mount. You know, I finally got to the point where I says, you know, I'm skipping ahead about 15 years, and I'm gonna get to the final point I'm gonna be in 15 years from now, but I'm gonna do it today so I'm not suffering anymore. And so that's when I found a good secondhand astrophysics mount. Best thing I ever did in my life. And that's what I bought. So this was back when I was still working.
That's the best thing.
Yeah. What's that?
Because the wife know that's the best thing you would.
She's not recording this, I hope. But yeah, that was, you know, I haven't had any headaches since I did that. And you really do need, your mount's all about, is everything, you know. It's nice now with the new strain wave mounts. They're definitely a lot sturdy, but you got to guide with those because the periodic error on those things are horrid. But in any case, yeah, the mounts. You're gonna put money on anything, put it on your mount. That's all I can recommend very highly. So, any other questions?
Drizzle.
What's drizzle?
Yeah.
Well, that's an algorithm that NASA came up with. And it requires you to, I don't know if any of you guys dither your images. So all that really means is that you're moving them at X number of pixels up, down, left, right to stagger it. And the idea behind that is you're not trying to get the same section of your DSO on the exact same part of your imaging sensor all the time. So what it does is it allows you to average a little bit differently in terms of, you know, how your sensor may react to light. So you need to dither in order to drizzle. And what drizzle actually does, yeah, I know. So what the hell is dither? Right. What drizzling does is it actually, I can't get into the math of it, exactly how it works by any means. I'm not even gonna even begin to explain it to you. But from what I understand, what it does is it looks at the image. The exact same image, two images where one is, imagine this is the center of one image, this is the center of the other. And what it does is it looks like it's looking like at the fraction of pixels, you know, what difference it is. I don't even know how to explain it.
It like splits the difference. It's like you're averaging. Yeah.
Yeah, but it's not just averaging. Pardon me?
Like, in other words, it's trying to figure out. It's two pixels side by side.
Right.
And there's certain brightness.
Right.
And it's moving on.
Right. All I know is what it generally does is it does the equivalent of resampling, meaning it actually makes a picture. I'm actually working on a galaxy right now called the Cocoon Galaxy. That's my current project, and it's pretty small. And what I think I'm going to try drizzling for the very first time. I've never done it in PixInsight. I'm going to try it. I'm going to see if I can get better resolution versus simply resampling. I'm going to actually compare what I get as a drizzle result with simply resampling the image a little bit larger to see if it's any better. You know, I'm curious. You know, maybe I'm not even going to bother drizzling anymore. Maybe the resampling does it. Who knows? But the idea is just to enlarge it in hoping that the resolution is such that you're still getting all that nice detail. So in answer to your, I didn't really answer your question, Russ, because I don't know the answer exactly how they do it. You explained it kind of, you know, we have pixels side by side, but I don't know exactly how it's working. Any other questions? Thank you. Thank you very much. Oh, thank you. Thank you.